All right, here we go. So today we're gonna factor quadratics. So we're basically gonna factor quadratics. Now, Mr. Adams, when I factor quadratics, I kind of use my own method. There are lots of methods that you could use. I like my method. It's kind of a guess and check, but it works well for me. So basically, remember the standard form of a quadratic looks like this: ax squared plus bx plus c can equal something. Usually we set it equal to 0 because we're going to try and find the zeros or the solutions of the factor. But for today, we're not going to focus on solving an equation. We're just going to focus on factoring the quadratic. And so let me just jump right in and we'll do problem number 1. They give us the equation x squared plus 9x plus 20. Now your textbook has a lot of suggestions. I'm not going to use any of them. So,
okay.
I'm going to write this out. Because basically what I'm trying to figure out is I've got some binomial times another binomial. When I multiply them out or FOIL them out, I'm going to get x squared plus 9x plus 20. But I know that the first and last term are going to be x squared, and then the last term is going to be 20. Well, the first term's easy. X times x gives me x squared. Now, here's what I got to do is I got to think of the factors. Actually, I'm doing almost exactly what the book says. I'm just organizing it a little different. I got to think of the factors of 20. But the factors of 20, these two terms, when I multiply this stuff out, these two terms have to not add up to 9x.
5 and 4.
Yeah, it's 5 and 4. So if I put a 4 in here, I multiply 4 times x and I get 4x here. If I put a 5 here, 5 times x is 5x. If I add these together, I get my 9x. So what does that mean? That means that x plus 5 times x plus 4 is x squared plus 9x plus 20. That's it. This is the answer. That's how we factor.
Reminds me of side when we did the cell.
I feel the same way.
I feel a lot easier than like the last.
Yep. So now let's try another one. You guys ready?
No.
I like how you guys said that in unison. No. Plus 14x minus 72. Now, this is still example 1. So this is like 1b, right?
That's an A.
Oh my god.
1b. All right. Shh, I'm good at math. So here we go. Same thing. First term, x squared. Last term, 72. I've got to remember that whatever I multiply, those two terms, when I add them up, they're going to be that middle term. So I'll do the first one. X times x is x squared. All right. So for the second example, in example number 1, we're given the equation or expression x squared plus 14x minus 72. I've taken the liberty of doing the first term, right? So my first term is x squared. I get x squared by multiplying x times x. Now the next term, or the last term I should say, is negative 72. So what I want to do is I want to find two factors of 72 that when I add them up or subtract them, they equal 14. Now, you might think 9 and 8, but if I add those up together, I get 17. If I subtract them and find the difference, I get 1 or negative 1, depending on how I do it. So the thing to do here is say 72 and just start dividing it by numbers, like 3. So 3 and 24,
No bueno.
if I subtract one of them, and because 72 is negative, I'm going to have to find the difference of these two terms, right? So if I subtract, say, 3 from 24, I'll get 21. So that doesn't work, so I just go 72 divided by 4. Wait a minute, now 18 minus 4, that will work, right?
That'll do it.
So that means what I'm going to have to do is I'll have like negative 18 here, or no, wait, positive 18, and then a negative 4 here.
Wait, doesn't matter which.
Yes.
Yes. Well, let me finish my thoughts. You guys are jumping ahead of me because you're excited. But basically, as long as one of them's positive and one of them's negative, when I multiply them out, I'll end up with a negative 72.
Mm-hmm.
But I want to do it in such a way that when I add these together, that I get a positive 14. So in this particular case, 18 has to be positive, so my 18 will be positive.
Yep.
There are scenarios where, like, if this was a negative 14, well, then I would need to have negative 18 and a positive 4. But now what does this mean? It means that x plus 18 times the quantity x minus 4 is the factor of this whole thing. Okay, question?
Does it matter, like, could you put the positive 18 at the bottom square? Put the negative 4 at the top one?
Yes.
Could
No, that doesn't matter.
Okay.
Ow! In other words, what he's saying is, Mr. Adams, what if I accidentally, he's worried about it. He said, okay, I do the same problem on my own on my homework, but I put the negative 4 here, negative 4x here, and 18x here, so that would mean that he has this and this.
Same thing.
It's the same thing.
Wait.
You would just write it like this. You would say x minus 4 and then x plus 18, but it's the same thing. And that's fine. Does that make sense?
Got it.
Okay.